Calculus kids, this is Dr. Callahan for week 15 Tuesday. How are you guys doing? Go ahead and pause the video and answer the following questions. All right, let's go ahead and take a look at question number 3. So for question number 3, you need to go ahead and do the curve sketchings for this, which means we're going to find the max and min and also point of inflection for the concavity. So first thing I'm going to do is I'm going to find the first derivative, which is just going to give me 3x squared minus 6s equals 0. You're going to use the power rule. And so if you look at this, you can factor out a 3 and factor out an x, in which case you have 3x parentheses x minus 2 set equal to 0 for your critical points. And there's going to be 2 of them. The first one is going to be 0. The second one is going to be a positive 2. So you're going to use these 2 points to test for max and min. After that, you're going to go ahead and to find the second derivative. Second derivative is going to be the power rule of the first derivative, which is just 6x minus 6. And we're going to set it equal to 0. We're going to add a 6 on both sides, divided by 6, which is going to give me a positive 1. And that is the only answer that you should have for your point of inflection for concavity. So this is going to be on curve sketching. So once you're done with this, we're going to start a chart on doing max and min and finding where the concavities are. So your chart starts with f of x, f prime of x, and f double prime of x. Now, your first one is going to start off with negative infinity to your first critical point, which is at 0. Your second one is going to start from x equals 0, which is going to be your x-intercept. Your next one is going to be from 0 to the next critical point of 1. And then after that, your next one is x equal to 1, which is going to be your x-intercept when y is equal to 0. The one after that is going to be at 1 to 2. And then the one following that is the x-intercept when x is equal to 2. And afterwards, 2 to positive infinity. So you're going to be taking the point of inflection along with their 2 critical points and to start this chart like this, okay? So then after that, we're going to go ahead and start testing some of our numbers, okay? So at this point, this is just simply the y value. When x equals 0, this is your critical point. You can put it back into f of x, and you're going to find out that y equals negative 1. Now do the same thing with the next critical point or point of inflection. When x equals 1, plug it back into f of 1. That is going to give you a negative 3. When x equals 2, that's your critical point. Plug it into f of 2, it is going to give you a negative 5. Now these are going to be your x-intercept. When x equals 0, these are going to be your critical point. When x equals 0, y equals negative 1. That's going to tell you whether it's going to be a max or min. I just don't know what it is yet. Then looking at the point of inflection, this is going to be the point of concavity. It is going to be at 1, negative 3. I don't know if it's going to be concave up or down, but I know that at this point there's a concavity. Next one is your second critical point. It's going to be at 2, negative 5. Okay. Then I'm going to take a look at the first derivative. With my first derivative, I'm going to pick a point negative infinity to 0. A good point to pick is negative 1. So I'm going to do f prime of negative 1. You could do second calc x value option, or you can just go ahead and plug it in here and do, like, for example, 3 times negative 1 squared minus 6 times negative 1. I don't know if it's negative 1. Negative 1 times negative 1 is a positive 1. Positive 1 times 3 is a positive 3. 6 times negative 1 is a positive 6. So obviously that's going to be a positive because of the positive 3 plus a 6. So you know it's going to be a positive. Okay. Then I'm going to take a look at when x equals 0, plug it in the first derivative right here. 0, 0 gives me a 0, obviously. Pick a point in between 0 and 1. A good point to pick is maybe 0.5. Put a 0.5 here. I know that 6, if I use a 0.5, is going to be a 3. And then when I have 3 times a 0.5 squared, it is going to be a smaller number. So negative 6 is going to be bigger than that. And because it's a negative, it's going to be a negative for that one. Now, when x is at 1, when you put it here, it is going to be a negative 3. Here, when you pick a point between 1 and 2, so you could do 1.5, plug into this equation for f prime of x, you're going to get a negative sign. When x equals a 2, you plug it in here. 2 times 2 is 4. 4 times 3 is a 12. 2 times 6 is a 12. So 12 minus 12 is a 0. Then you're going to pick a point from 2 to positive infinity. You could pick 100 if you want, but I'm going to pick 3. So 3 times 3 is 9. 9 times 3 is 27. And then 3 times 6 is 18. 27 minus 18 is going to be a positive. So this is your second column. Then you're going to take a look at the f double prime of x. Okay, so this is your chart right here. So pick a point in between negative infinity and 0. And again, a good number to pick is just negative 1. So plug into the second equation. 6 times negative 1 is a negative 6. Minus 6 is going to give me a, I'm sorry, negative 1 times 6 is a negative 6. Negative 6 minus 6 is a negative 12. So you know that between negative infinity and 0, it's a concave down. When x equals 0, I'm going to go ahead and plug it a negative, okay, negative 6. A good point to pick between 0 and 1 is a 1/2. Plug it into the second derivative. You're going to get a negative. Same thing over here. X equals 1. It's going to give you a 0. Picking a point between 1 and 2, 0.5. 6 times 0.5 is going to be a 3. 3 minus 6 is a negative. I'm sorry. 0.5. I'm sorry, it's 1.5, not 0.5, 1.5. 1.5 times 6 is going to be bigger than 6, so that's a positive number. Minus 6 is going to be a positive. And then when x equals 2, you're going to plug it in here. That's going to give you a 12 minus 6, which is going to be a positive. And then a good number to pick between 2 to positive infinity is 3. 3 times 6 is going to be a 18. 18 minus 6 is going to be a positive. Okay, so now that you fill out this chart, okay, you're going to have some conclusions. Your first critical point is at 0, negative 1. At this point right here, you can see it's going from a positive to a negative, so up and then down. So that is going to be a relative max at 0, negative 1. Then take a look at your critical point for number, actually we can just jump over to point of inflection, that's fine. So point of inflection will tell you whether it's going to be a concave up or concave down. We'll take a look over here. It's going to go from a positive to a negative, and from a negative to a negative, and then negative to a positive. So your point of inflection is going to be at 1, negative 3, okay? And look at this, if you take a look at double prime of x, between negative infinity all the way over to 1, it is all concave down, okay? But from 1 to positive infinity, it is concave up, which comes to our second critical point, whether it's a max or min. We'll take a look at the first derivative. From a negative to a positive, that is going to give you a negative, positive, so it's going to go down like a valley and then up. So it is going to be a relative minimum. Okay. And so this is kind of the chart. This is a curve summary of what you can do. If you were to go ahead and graph this using this information, your graph will look something like this. And the reason why it will look like this is you start off with your relative max at 0, negative 1. At 0, negative 1, there's your max, okay? And you know that on if you look at the second derivative, it is concave down. So on the left side, it is facing down. And also from negative 1, you have the right side of this part. It's also concave down. Look at it, it's still concave down. Then it comes to your relative minimum, which is at 2, negative 5. So here is 2, negative 5 right here. All this minimum right here. And then your point of inflection is at 1, negative 3. 1, negative 3 right here. And that's good to have because if you look at it, this is where it's kind of the break is, okay? The change of concavity. Everything on the left side of negative 1 is concave down. Everything on the right side of negative 1 is concave up. And so this is how you will go about graphing it. All right, so I know you're like, wow, that was a lot, and it is, but it's a good work to go ahead and go over this. All right, so then what I want you guys to do is, because we're on the subject of sketching, go ahead and turn over to your notes for week 15 Tuesday. And with your notes, you should be able to see on your first page, it looks like this. There we go. So this is a summary of curve sketching. This is a guideline for analyzing the graph of a function and determining how to go about with your curve sketching. Then take a look at the 4 examples I have. I have 4 examples with the steps and the chart, okay? And then of course the drawing. 1, example 2, 3, and 4. 3, and then 4. Okay, they're on separate pages. If you look at the f of x, they're all different. This is a pretty easy one with the exponent. 3 has a square root. 4 is our second one is in a form of a fraction. The first one is kind of like a chain rule. I guess it's more like a distributive. I guess it's not too bad if you distribute the negative 1/3. So they're all different in the way that they're written. Okay. So then take a look at this page here. And I'm sorry you don't have this in your notes. I'm going to pass this out in class. I actually just created this. So look here. These are two different parts of first part is sketching the first derivative and the second derivative graph given the f of x graph. Then number 2 is sketching the graph and the second derivative graph given the f prime of x. Okay, so go ahead and read this and determine how do you go about finding the critical point for the maximum, the point of inflection for the concavity. Pause the video and do that. Okay, so now what I want you guys to do is take a look at the 4 examples that's on curve sketching that I just showed you guys, and then look at example or the reflection options 1, 2, 3, and 4. Answer them on a separate. Pause the video and do that. Now that you have read the left part of this, you are now ready to go ahead and draw your own sketching, and we're going to practice them today. So we're going to take a look at this guided note right here. This is also passed out. I'm sorry it's not in your guided notes for 2020 semester 1, but if you're 2021 semester 1, this will definitely be your guided notes. So I apologize for that. But if I see tomorrow, you'll definitely be able to get that. So let's go ahead and take a look at the first example. So what's given to you is the f of x on this graph. And so looking at this, this is just f of x. Remember, f of x is just a simple graph with the max and min already in there. So if you look at the critical points are where the max and mins are. Okay, so your critical points in this case is x is going to equal to -3, which is right here, -1, and +1. So these are your critical points. So then from there, I'm going to do a sign line so I can notate where they're located. So -3, -1, and +1. Now I'm going to go ahead and find my slope based on the curvature of this graph. So let's take a look at the first one. So at -3, it is a negative slope. So I'm just going to draw my slope. I'm sorry, it's a positive slope. What am I talking about? Positive slope, so I'm just going to put positive. Okay. Now, between -3 down to -1, it is a negative slope. So I'm going to put a negative right there. And then between a -1 to +1, it is a positive slope, so positive. And then after that, it is a negative slope, so negative. So now that you have this part here, I'm going to go ahead and draw my new graph, which my new graph is going to be f prime of x. And then remember the rule is that if it is going to be a positive slope, it needs to be above the x-axis if the slope is a positive, okay? And then vice versa, it needs to be below the x-axis if the slope is a negative. So first thing I'm going to do is I'm going to find my points, which are the critical points. 1, 2, 3, there's your critical point. -1, +1. Okay, let's go ahead and doodle around to find them. All right, so at -3 on the left side, it's a positive slope. So that means your graph is going to be above the x-axis. Now, at -1, it's a negative slope. So it's going to be below the x-axis, but it needs to be meeting. You can't just have this hanging like all the way down here past -1, because after -1, notice it's a positive slope, but you can't go above the x-axis. Like you cannot have that break there. So what do you do in this situation? You have to link it like that, okay? So it meets right there at -1, because at -1's a positive slope now. But then be careful, because a positive one's a negative slope. So you're gonna go up and then down like that. And then after a positive one, it's a negative slope once again, so it goes below the x-axis. So that is your first derivative of drawing, okay? Now, we've done this before in the second unit, but the third unit, we're going to continue on with point of inflection as well, okay? So your point of inflection is when the concavity changes. And if you take a look at this, when does the concavity change? Right here, POI x equals -2. And up here, POI equals 0. And I know that because this right here is the min and that's the max, and that's where the concavity changes. The -2 is a concave up, negative or 0, it's a concave down. So I'm gonna go ahead and say my POI is x equals -2 and x equals 0. So then I'm gonna go ahead and put the -2 right here and 0 on my POI. And then what I'm gonna do with this is I need to go ahead and take a look at my f prime of x, the first derivative, on the left side of -2 to determine is it a concave up or a concave down. So if I look on the left side of -2, it is going to be determining on the slope. It is a negative slope, if you can see this right here. And because it's a negative slope, slope equals negative. Therefore, it is a concave down, okay? Then we're going to take a look in between -2 to 0. So here's -2 to 0. Oh, it's a positive slope. So if the slope is positive, you know it is a concave up. And then we'll take a look at after 0, and it's going back to negative again. So what that means is it is a concave down. All right, so let's go ahead and graph this because we've not done this before. So you can start off with -2 and add 0. Okay, so then on the left side of -2, it is a concave down. Between -2 and 0, it is a concave up. So the rules of this is going to be, if it is above the x-axis, and actually I should go ahead and erase that. I shouldn't do that just yet. If it's above the x-axis, it's a concave up. And if it is below the x-axis, it's a concave down, like that. Okay, so let's draw this down. So at -2, it is a concave down, so it's below the x-axis, okay? At 0 to the right side, it's a concave down, so it's below the x-axis. But then, in between -2 and 0, it is a concave up, so it's above the x-axis. So your graph will look like that for the second derivative. And that actually makes sense because, actually, if I have the equation, you'll be able to graph it, but I don't have the equation, so never mind. Just kidding. All right, so then let's take a look at example 2. For example 2, go ahead and pause the video and give that a try on your own. Okay, so for number 2, I'm just going to briefly go over this. Your critical points here are going to be looking at the max and min values. And so for those, there are 3 of them, and that is going to be a -2, 0, and a +2. So on your sign line, if you take a look at the slope, negative, positive, negative, positive, you'll be able to see that negative on the left side of -2 positive in between 2 and 0, negative in between 0 and 2, and then positive after 2. So then with these slope, remember, if it is a positive slope, it is going to be above the x-axis, and then it is going to be below if it is a negative slope. So then your graph is going to be at -2, 0, and +2. So then on the left side, -2, it's a negative, so we go below. Now in between -2 and 0, it's a positive, but remember you got to meet it from, meet from one side to the next. You can't just have it hanging all the way up. Okay, so it has to go like this little curve. And then at 0 to +2, it is negative. And then above 2 to positive infinity, it is a positive slope. So that is your graph for f prime of x. Take a look at your point of inflection. For your point of inflection, you have 3 points here, or 2 points here. And remember, you're looking at the max and min of this. It's the first derivative. And it is at x equals -1 and x equals +1. So here is my -1, and here is my +1. So then we're going to look at the slope of this f prime of x. Negative slope, positive slope. I'm sorry, positive slope, negative slope, positive slope. So I'm going to put negative or positive, negative, positive. So then what you're going to do with the signs here is that because on the left side -1, it's a positive slope, it's a concave up. In between -1 to +1, it is a negative slope, so it's a concave down. And then +1 to the right side is a positive slope, so it's a concave up. So then let's go ahead and take a look at the graph here. You're going to be plotting -1, +1 right here. And then we're going to go ahead and draw this. Okay, remember, if it is above, it is a concave up. If it's below, it is a concave down. So left of -1, it's a concave up, so it is going to be above. Right side of 1, it's a concave up, so it's going to be above. But then in between, it's a negative, or it's a concave down, so it's going to be below, like that. And that is your f double prime of x. If my pen worked, I would completely draw this correctly. All right. Okay, guys, let's go on to example 3. So with example 3, if you take a look at this, you have a graph right here. Just keep in mind that everything on, well, actually this one's different because this one says f prime of x. So we're actually going on the reverse of this. Okay, so I like to label everything. So anything that is above the x-axis has a positive slope. Anything that is below the x-axis is going to be a negative slope. Okay, so then let's go ahead and draw our sign line. If you look at this right here, you have 3 critical points at -3, -1, and 1. Oh, you know what? I'm sorry. Hold on a second. That's not correct. No, it is correct. Just kidding. Sorry. -3, -1, and +1. All right, so then looking at this here, looking at the slopes, on the left side of -3, it is a positive slope. In between -3 here, it's a negative slope. Between -1 to a +1, it is a positive slope. And then from 1 to the right side, it's a negative slope. This is going to tell you about concavity. So I'm just going to say that in between -3 to the left of that, it's positive, so it's concave up. Between -3 and 1, it is a negative, so it's concave down. And then between -1 to 1, it is a positive, so it's a concave up. And then after 1, it is a negative, so it's a concave down. So let's take a look at this part here. We're going to go ahead and so this is a second derivative. We need to go kind of backtrack a little bit to the first derivative. So the first derivative sine line, you're going to look at when slope is equal to 0. Because x-axis is here, slope is at 0, the critical point is going to be at the x-intercept. So this point here, -4, -2, and 1. Yeah. So here's my first one, and I'm going to have a -4, -2, and +1. So I'm looking at -4 on the left side of that. It's below the x-axis, so it's a negative slope. So it's going to be like this. It's a negative slope. Okay. In between -4 to 2, it's above the x-axis, so it's a positive slope. Whoops. So it should be like this. Then between -2 to 1, it is below the x-axis, so it's a negative slope. And then after 1 to the right side, it's below the x-axis, so it's also a negative slope. So let's now sketch the f of x. Okay, so this is f of x, not f prime of x or f double prime of x. It's just f of x. We're going to go ahead and plot the -4, -2, and a 1. So here is -4. -2, and +1. So those are my dots. Obviously, they're going to be shifting a little bit because I don't know what the height of this is. But I know that at -4, it is a negative slope. So I'm going to go down to -4 right here. And I know it's going to be a negative slope, so it's going to look something like this. Okay. And this right here is going to become a minimum. Okay, so that's going to become a min. And then from -2, from positive to a negative, it is going to be a max. Okay, so then at -2, here's -2. I'm just going to go all the way up here somewhere. So I have here -2. There we go. And then from -2 down onward, it is going to be a min again. And if you look at the +1, there's no change. So it's just going to go from up, whoops, and down like that. And that is how your graph will look like. Okay, so then looking at this part right here is a sketch f double prime of x for the graph. All right, so with this one, you're going to be using your sine line right here. These are the points you're going to be using. 3, -1, and +1. So 1, 2, 3, here's my -3, -1, and +1. All right, and then from here, if you look at the concavity, left of -3, it is a concave up. From -3 to -1, it is a concave down, which means, remember, if it is concave up, the rule is that it's above the x-axis. Come on, word pen. And then, of course, if it's concave down, it's going to be below the x-axis. So between -3 to 1, it is below the x-axis. So I'm going to have to do something like this. But remember, it has a meet. And then between -1 to 1, it is going to be a concave up. So above the x-axis like that. And then after 1 to the right side, it is a concave down. So below the x-axis. So it looks something like this. All right, so now we kind of work backwards and forwards with drawing, the graphs of this. So now let's talk about increasing and decreasing. So characteristics of f of x. if you look at the original equation, when is it increasing? It's increasing between -4 to -2. I'm going to go back to this. So -4 to -2. When is it decreasing? It is decreasing, meaning that it's going to be going downwards at -infinity to -4, union from -2 to -1, union from 1 to positive infinity. If you take a look at this right here, we can go ahead and match it from -infinity to -4 right there. From -2 to -1 right there, still going down. And then from 1 to positive infinity, so negative right there. Here is going to be your relative maximum. Your relative maximum is x equals -2. Relative min, x equals -4. Concave up is going to be between -infinity to -3, union -1 to +1. And concave down is from -3 to -1, union 1 to positive infinity. And then your point of inflection is at -3, -1, and +1. Phew, oh my gosh, that was long. So now that we've done this, take a look at this, kind of soak it in a little bit, look at the rules. I know it's a lot to memorize. And then when you are ready, go ahead and give example 4 a try on your own. All right, you guys, that is all that I have for you guys today. It was a lot. I hope you guys are doing well. Stay safe and healthy. Wear your mask, and I'll see you guys next time. Take care.